Hey Trig, I just wanted to go over the homework before we start 7-3. I want to highlight these things that happen with the ambiguous case. I know that that gets confusing, but it's not as confusing anymore now that we understand inverse trig and how it works. I just want to show you how I reason this out, okay? You go along, you use the law of sines, right? Not a big deal. I draw my triangle the same every time. They're not drawn to scale. I don't know if that's, you know what I mean? I just do ABC. I just draw ABC and I fill it in. Okay, so C is 52.3 degrees. The opposite side of C is lowercase c, which is 59.8. I didn't know A or B, but I knew that side A, opposite angle A, was 32.5. So I set up the law of sines. The sine of 52.3 divided by 59.8 equals the sine of A over 32.5. You cross multiply, you divide. I took the inverse sine of this and got 25.5 degrees. But then I know from the unit circle that there's another spot where that the sine of that will give me this positive answer. Okay? The sine of what angle gives me this positive answer? Well, it could be 25.5 degrees, or it could be this, 25.5 up from 180. So I took 180 minus 25.5, and I'm like, it could be this too. There are two different angles such that when I take the sine of it, I get 0.4300129. Okay, and then I just figure out the other. Now I have two angles, right? If it's 25.5, if A is 25.5, I added 25.5 plus 59.3, subtracted that from 180, and I said, okay, well then B would be 102 degrees. Well, what if A was 154.5 degrees? I did the same thing. I did 52.3 plus 154.5, and I was already at 187 some degrees. So there can't be another triangle, okay? B would have to be -7. That can't happen. So then I was like, good, there's only one triangle. We go along and solve it the rest of the way, just as you did your other problems, okay? We figured out, I did the law. What did I do? Oh, here, I show you what I did then. Okay, you can pause me and look at that if you'd like. Same thing with 24. Okay, remember, this only happens when you have angle side side. You can think about what that spells. A-S-S. And then that's what I always just know. I'm like, oh, you know, this is going to be a pain in the A-S-S. Okay, so anyway, we go along here. We take sine of 68.5 over 258 equals sine of B over that. I go along. I do inverse sine, and it's a big error. It gives me an A. I can't take sine of what equals something over 1? The range of sine is between -1 and 1. No. So then when there's no triangle, my calculator just tells me it's heavenly. This can't happen. This situation here is not going to make a triangle. Oh, and then so number 30 is the third type that happens. Okay. Okay, so the third type that happens here is I just can't tell if you can see it. All right, you can. Again, I drew the little triangle. I went up a little too far, didn't I? Okay, I drew the triangle. I notice I have angle side side. So anyway, I take sine of 51.2 over 7208. I find what C is. I realize that there's another angle such that the sine of C will give me this positive answer. It's 180 minus this. And then I try to figure out the two triangles. I take 180 minus the 51.2 minus what I think C is, 59.7. And I realize that B could be 69.1 degrees. Well, what if C is 120? Then I take 180 minus 51.2, just like I did over here, but now I minus 120.3. Oh, I could have a little tiny 8.5 degree triangle. There's two different B's. So I have two different triangles. So then I figure out what side B would be in each case. Okay, side B might be 8640 if angle B is 69.1. Side B could be 100, whatever this is, 1367 if angle B is 8.5 degrees. Okay, you get two triangles for 30. So I just wanted to go over the three things that happen with the situation when you have an angle side. Maybe there's just one triangle, maybe the triangle can't happen, or maybe you have two possible triangles with the given information. Okay, let's look at this situation and see if we can do this law of sines with this. The surveyor wishes to find the distance between two inaccessible points A and B on opposite sides of a lake. While standing at point C, she finds that the distance from there to there, you can shoot a little laser. It's 259 meters. And she finds out that the distance from C to B, which we're letting will be A, is 423 meters. Okay, we know this angle between the two, and now we'd like to find this distance. So, let's see, I'm trying to set up the law of sines, so we do the sine of C, sine of 132 degrees 40 minutes, over side C. I need one of these angles, okay? I can't, do you see it? I don't have A. I don't have B. I can't use the law of sines for this, guys. Okay? It's the one situation when we can't, when we have side, angle, side. An angle in between two sides. So that's when we have to use something called the law of cosines, which I know you learned in geometry as well, honors geometry. But anyway, here's what I like to, here's how I memorize it. All these letters drive me nuts. Okay, whatever side I don't know squared is going to equal the other two sides squared added together minus twice those two sides times the cosine of the angle opposite the side I don't know. Okay, whatever side I don't know squared, the other two sides squared minus twice those two sides times the cosine of this angle. Don't measure. Memorize the process, not the ABC-ness. Okay, so hey, let's go back and do that problem. I'd like to do that instead. Now that we know this. Okay, I'm going to know the distance for this poor girl. All right, so we're going to take the side I don't know equals the other two sides squared minus twice those two sides times the cosine of the C angle. 132, go away. 132 degrees, 40 minutes. Okay? See how great, I love the law of cosines. Go ahead and pause me and see what you get. I'm going to pause myself. Okay, I hope you paused me and you did it yourself. That'd be great. And hopefully this is what you got, 628.1. Now be careful, guys. You don't just enter this whole thing in your calculator. I mean, maybe it worked out okay, but you have to realize you can't do this thing squared plus this thing squared minus twice this, and then hit enter. Okay, sometimes people do the numbers and they hit enter. This is what I got for when I added those two together, minus, this is all multiplied together. This is all one term. It's this term minus that term. Okay, it ended up being minus a negative. Of course, that's what C squared is. So C was 628.1 meters using the law of cosines. Okay, so if I'm asked to solve this triangle, again, I don't care if this looks right or not. A is 42.3 degrees. Opposite of A, I don't know. Side B is 12.9. Side C is 15.4. I realize I have the situation of the law of cosines because I have side angle side. Okay, I'd like to get side A right away. A squared equals 15.4 squared plus 12.9 squared minus twice those two cosine of 42.3. Okay, so we get 15.4 and 12.9 in there. Again, let's do that on our calculator. And you pause me, please, and then we'll check your answer. Please pause me. Okay, hopefully this is what you got when we set it up. I just want to make sure you can use your calculator correctly. Make sure your mode's in degrees. And you get a squared is about 109.7. A is about 10.5. Okay, now that I have what A equals, I just resort back to the law of sines to find my others. Okay, I'll take the sine of 42.3 over my 10.5. Sorry, equals the sine of C over 15.4. And then once I get C, I would just subtract that from 180, to tell you the truth, to get B. So I use the law of cosines. I use the law of sines. 10.5 sine C equals whatever sine of 42.3 times 15.4 is. Okay, if you do the sine of 40, okay, let's pause me and do that math. Okay, so we got what A squared equals and what A equals using the law of cosines. And now I'm using law of sines to get this answer. Oops, 42.3. You get the sine of C equals that divided by 10.5. That's what the sine of C would equal. I'll do the inverse sine of both sides. End up getting C close to 81.7. Okay, and then I would just subtract. I'm going to take 42.3 plus 81.7 and subtract that and get about 56 degrees for B. Okay, all right. Here's another example when I have all three sides and no angles. 9.47 is A. 15.9 is B. 21.1 is C. I have to use the law of cosines here, gang. Okay, let's set it up. Let's find A first. Doesn't matter. I'm just picking A. Okay, so I know that A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. Please be very careful with this, guys. Do this addition, subtract it from here, and then you divide by this before you take the cosine. Okay? Let me make sure I'm not out of time. Okay. All right, let's do this step by step. Okay? I'm gonna put the work up so that I can go through it without writing. Okay, so what I mean is I square this, I get this. I squared this, added it together. I got this. Minus 2 times this, cosine A. I'm going to subtract the 698.02 from both sides. Okay? When I subtract that, I get this negative number equals negative 670.98 cosine A. What happens is people do the 698.02 and they subtract 670.98. And then they take the inverse cosine. You have to divide. We get all kinds of weird answers then. You have to divide both sides by negative 670.98 and then take the inverse cosine of that answer. Okay, when I divided this, I got 0.90664 equals cosine A. I took the inverse cosine of both sides, and I got A to be about 25 degrees. From there, then, I'm ready to do the law of sines to get the other angles. Well, law of sines and then subtract. Okay. The law of sines and subtracted from 180, I got B to be 45.1 and C to be 109.9. Okay.